Hello everybody and welcome to our next video. This one is on conditional statements. Don't forget to take notes as we continue through these. We've got some really crucial stuff that we're going to be talking about today on conditional statements and how to rewrite them, and terminology is really going to be super important for you to understand here. So just make sure that you are writing down everything that you need to, some really key vocabulary and all of the examples. All right, so let's start with what a conditional statements are. These are if-then statements. And we're going to really be talking about their truth values. So a conditional statement is an if-then statement. Okay, it comes with two parts. The first part is called the hypothesis. It is the part, or P, following the if. The second part of our conditional statement is the conclusion. It is the part where we usually call it Q, following the then. So when I'm referencing P and Q, as you can see here and here, we're talking about if P, this means kind of like that implies, or then, and then this is Q. So these are going to be two specific statements that we're going to be putting in here, and then we're going to put together to form our conditional statement. So it's read as if P then Q, or like I said, P implies Q. So you may need to show that a statement is true or false, and this is finding our truth value. And that's just determining whether or not a statement is true or false. So if I were to say something to you, it could most likely is going to be about a geometry term, then you can say that that is true or false, knowing what we know about geometry. So a big note here is to show that something is true. Remember, you have to show that the hypothesis is going to be true every time, and the conclusion is also going to be true, or every time that the hypothesis is true, that the conclusion also has to be true. It can't be true for just the hypothesis and false for the conclusion. And then to show that conditional is false, just like we talked about in that previous lesson, is all you have to do is find one counter example. So it's important to understand what the hypothesis and conclusion are of a conditional statement. So let's do an example. This is a conditional. If an animal is a robin, then the animal is a bird. So as you can see, we have this if and then portion. So if I want to identify just the hypothesis, that's the first part, the if, then it would be an animal is a robin. The conclusion would be the second half of the statement after the comma there, which would be that the animal is a bird. So sometimes I can give you a sentence like an animal is a robin and then it is a bird, or a robin is a bird, something like that. Then we have to split it up to our hypothesis and conclusion. So the robin, or the if part, is usually a more generalized, while the then part is usually a more specific. Okay, so we have a couple different types of statements that we have. They're called the conditional, converse, inverse, and contrapositive. So this is a super helpful chart because you're going to not only have the description of everything, I'm going to give you an example and how we read it in terms of like P's and Q's. So the conditional statement, like we just went over, we use the given hypothesis and the conclusion. Sometimes it's going to be some kind of a statement, like I was saying the last one, say, you know, like a robin is a bird, and you would have to figure out what the hypothesis and the conclusion is. Okay, so an example would be if the measure of angle A is equal to 15, then angle A is acute. So in terms of P's and Q's, this would be if P, then Q. So now the converse, inverse, and contrapositive takes these statements and manipulates them. The converse, what we're going to do is exchange where the hypothesis and the conclusion are of the conditional statement. So in our example, I'm going to switch everything. Okay, I call these the flip. So what that means is I'm going to say if angle A is acute, then the measure of angle A is equal to 15. Okay, so the if Q, then P. Now I can go ahead and start assigning my truth values here. If this original one, if its angle A is 15, then it has to be acute. So this is a true statement. But for the second one here, if angle A is acute, then the measure of angle is equal to 15. That's not necessarily true. It could be, say, 20 degrees, okay? So that we would consider to be a false statement when the converse is false like that, okay? All right, inverse. Now, to take the inverse, what we're going to do is take the original conditional statement and we're going to negate both of them, meaning making them the opposite value. So, for example, in our hypothesis originally said if the measure of A is equal to 15, we're now going to say if the measure of angle does not equal 15. Okay, and then instead of saying then the angle A is acute, we're going to say then the angle A is not acute. So you see how I'm quote unquote negating that? Now if it originally had some kind of negative connotation, like the original conditional statement said then it was not 15, then down here we would say that it is 15. So it's always going to be the opposite of what the conditional statement is. So I call this the not. Again, this is based upon the conditional statement. So not not P, then not Q. You're going to make it the opposite. The last one we have is the contrapositive. This is the one I like to call the flip, not not. Okay, it's essentially negating the converse. So I'm taking the hypothesis and the conclusion of the converse, which is this statement right here, and doing the opposites with that one. So instead of saying if angle is acute, then the angle A is not acute. And then the measure of angle A is 15, then the measure of angle A is not equal to 15. And that's what this means here. This equal sign with a slash, that means not equal to 15. So I read this as if not Q, then not P. So you have the conditional is the original statement with using the hypothesis and conclusion. The converse is the flip. So I'm switching where the hypothesis and the conclusion are. The inverse is my not not. So I take the original conditional and I switch it to the opposite kind of sign there. And the contrapositive is my flip not not. Again, that's all in relation to what the conditional is. Sometimes all statements are true. So looking at this here, these first statement and this one here are true, but the ones in the middle are actually not true. Because if it's not 15, it could be something else. It doesn't necessarily mean if it's not 15, it's not acute. But if it's not acute, then there's no way that it can be be 15 degrees. So sometimes all statements are true, and then this is the case, we can write something called a biconditional. And this is one single true statement that's going to combine a true conditional and its converse. And what we do is join the hypothesis and the conclusion by saying the phrase if and only if. So this can happen if and only if this happens. Like you can get an A in this class if and only if you get A's on everything. Now obviously that's not the case, but I'm just trying to say is that this is only going to happen given that the second thing happens, okay? So here's an example. What is the converse of the following? What is the converse of the following true conditional? And if it is also true, so we're focusing really on the converse and the conditional. If those two are true, we're going to rewrite as a biconditional. So here's our original statement. If the sum of the measure of two angles is 180, then the two angles form a straight angle. Okay, so if we put two angles next to each other and they add up to 180, that's going to form a straight angle, and that's true. Okay, because two angles next to each other, a straight angle is equal to 180. So the converse, if two angles form a straight angle, then the sum of the two measures is 180, and that is also true. If I had a straight line and I had two angles that are making up that straight angle there, then it has to add up to 180. So since these two statements are the true ones, we can now write a biconditional. What I want you to note is that I no longer say if this, then this. Instead, I start with the original hypothesis. In other words, the sum of the measures of two angles is 180. Okay, as I can see right here, the sum of the measures of the two angles is 180. And here comes the new part. If and only if the two angles form a straight angle. So you see how I no longer have if-thens statements. I now have the two hypotheses and the conclusions with a combination of the if and only if in between. That means this can only happen if and only this is going to happen. Okay, so we want to do another one here. What is the converse? If it's true, write the biconditional. So here's my statement here. Let me go ahead and change those colors. Hold on. There we go. That's much better. So if the sum of the measures is two angles is 180, then two angles form a straight angle. The converse, if two angles form the straight angle, then the sum of the two measures is 180. So you kind of see I'm now highlighting those specific pieces here. So the yellow is one of them. I'm doing the converse, which is the flipping. And now in our final thing here, the sum of the measure of the angles is 180, if and only if. So you see how I don't have this if and I don't have that then. I know this is the same example as before. Okay, but it's just kind of highlighting it in just so you can get a better visual of it instead of just seeing the words like that. All right, continue on. Adjacent angles are two angles that share a common vertex and side but have no common interior points. Sorry about that. All right, so what I'm going to do, see how that's a statement? It's not a conditional at all. It doesn't say if then. So the first thing I'm going to do is change that to a conditional. So the first thing I'm saying is that it's talking about adjacent angles. So if two angles are adjacent. Now let's get more specific. If two angles are adjacent, then we have the rest of it. They share a common vertex and side, but have no common interior point. Sorry, side was left out right there. So then the converse is going to flip these two statements. So you see how the white now becomes the white statement here now becomes the hypothesis, and our green color here becomes our conclusion. So I'm flipping that. And I wanted to say, well, are these two things true? If two angles share a common vertex, have no common interior points, then the angles are adjacent angles. And that is true. So I'm going back to my original statement. I'm putting the if and only the if inside. Again, see how there's no if out front here and there's no then here. So please be careful with that. Don't write if two angles are adjacent, if and only if, then they share a common vertex and sides but have no common interior points. Make sure your sentence makes sense. You don't want to have something in there that doesn't make sense for in English. Okay? I know that I'm missing the word sides here, but you know what I mean. Okay, so hopefully you got a good introduction to biconditional and the different types of conditional statements. You're going to have the opportunity to practice this a lot more. So go ahead and stop this video and go ahead and start working on your practice.